This is a revision video for grade 10 motion graphs as well as for grade 12 later on. The first example is constant velocity. Now this looks like a ticker tape, but it's also, this one is made by an oil droplet that is coming from the back of a truck, and it is constant velocity, therefore the distance between the dots are equal. Therefore, if you look at the displacement time graph, the first one, you will have equal spacing here for your change in position, the delta x, over the delta time versus the delta t, so therefore it will be a straight line. If you then go to the velocity time graph, it is a constant velocity since you get the velocity from the displacement time as the gradient of the line. So there's my straight line, which is giving us a straight line, constant gradient, so therefore velocity is constant. Then the gradient of the velocity time graph gives you the acceleration. In this case, it is one of your special graphs, which is a y equal to a number. There's no gradient, therefore the displacement is 0. If you then work backwards, if you take the acceleration, which is now being 0 meters per second squared, the area under that graph is 0, therefore the change in velocity in this graph, the change in velocity will also be 0, and the area under the velocity time graph will give us the displacement, the change in displacement. Right, the next motion is accelerated motion. You can now see on the road that the space between the dots, the distance between the dots are increasing, therefore the truck is going faster. The displacement time graph will then be, if you look at the delta x-axis, the spacing here will increase according to the increase in the dots. Therefore, you will have a curved graph. The tangent of this graph, which is just a straight line touching, the gradient of that tangent will give us the velocity time graph like we had in the previous slide. And you can see that this is clearly an increase in velocity starting from 0 to wherever it increases. And then the gradient of your velocity time graph is going to give you the acceleration time graph again. Now, the gradient of the velocity time graph is clearly a constant value, so your acceleration is going to be a constant positive value because it's a constant gradient. And if you work backwards, the area under the acceleration time graph will give you the change in velocity, whereas the area under the velocity time graph will give you the displacement. The next one is for decelerated motion. Now you see that the truck is slowing down, the distance between the dots decreasing, therefore the distance here between the measurements will decrease. It's a curve down for a deceleration. Therefore, tangent of the gradient will now decrease. It starts from a high velocity here, which is a straight line there, to dropping to 0. And then the gradient of this line is clearly negative. Therefore, the gradient of the velocity time graph will again be a negative value in this case. To get the reverse, the area under the graph will give you the change in velocity, and the area under the graph will give you the change in displacement. Now we're going to look at this graph and typical example in which you need to describe the motion. From 0 to 2 seconds, you start from rest. Now take note, it is a velocity time graph, right? You start from rest and the constant acceleration for 2 seconds. From 2 to 5 seconds, it is a constant velocity that is reached, and it is kept on 10 meters per second for the 3 seconds. And it maintains going west, and then from 5 to 6 seconds it is negative acceleration or deceleration, and the vehicle is stopping. Then from 6 to 7 seconds, now I told you that when velocity time graphs go negative, it means that the direction is changed for this object that is moving. Now this one is a car that's going west at a traffic light, so that the direction for the movement from 6 to 7 will be east. Constant acceleration to reach velocity 10 meters per second east take note that there is a change in direction. What I'm going to do now is I'm going to show you how to draw the displacement time graph for this motion as well as the acceleration time graph from this velocity time graph. I'm going to show you how to draw the displacement time graph for the velocity time graph that was given in figure 21.8. So always name your axes by saying what is the variable that you're going to plot and state the unit. Please remember that, otherwise you will lose a mark. So for that sketch we have time indications of 2, 5, 6 and 7. So it's 2, 5, 6, 7. Again, I'm not measuring anything, it's just a rough sketch. And then for the first part, I see that there's a velocity increase from 0 to 10. Now, how do we get the displacement from a velocity time graph? It is the area under. So you simply need to calculate the area. It's half times 2 times 10, which is equal to 50. So it's half times 2 times 10, which is equal to 10. So I know that the first part is 10, and again I'm not measuring anything. It is an increased velocity, therefore it must be a curve up, like that. The next part is constant velocity, therefore the displacement time again is the area under, and that area is, the bottom part is from 2 to 5 seconds, so it's length times breadth. So it is 10 times 3, so it is 30 meters. So you will have to go up 30 meters here. That brings us to 40, and it is going to be a straight line. It's constant velocity. Velocity is the gradient of this, so straight line. Then he is decelerating from 10 meters per second down to 0, and that is also half times 10, so it is 5 meters, and he's decelerating for 5 meters. That's going to bring us to 45. And that's decelerating, so it's going to be curved down. Just make a dot there where you see the change. And then the last part is also for 5 meters. He's going to turn back. How do we know that? Because on the velocity time graph, it is going below the time axis. And as I said, velocity time shows us the direction. So if it's negative, it means that he's going backwards. So for another second, he is going to turn back. Always make a dot where there's a change in the motion, and that is your displacement time graph for that velocity time graph. Then I'm also going to show you the acceleration time graph. Now, acceleration will have positive and negative parts. So there's my acceleration. It is in meters per second squared and delta t in seconds. For the first part, it is a positive acceleration. So again, use the same time readings, 2, 5, 6, 7. For the first part, it is a constant, and the gradient of that part is 10 over 2, so it is 5. So it will be at 5 up to 2 seconds. Then the next part is constant velocity, so he's going to be on the time axis. The next second is negative acceleration of 10 over 1, so it's going to be a deceleration of minus 10. So it's going to be that part. And then he has a further deceleration, the same, and it's going to go on like that. And again, this part, the deceleration here in the last second is acceleration in the opposite direction, because he had to stop at 0 meters per second and he turned back, right? So this is a very important exercise that you should be able to do. Thank you.